Alright, so I'm gonna be talking about mutations in this video. I've noticed that you guys are learning more about mutations and repair. So I might as well just give you guys like a quick review of what mutations are. So mutations are permanent change in the DNA sequence. If you remember from one of the slides, you've seen like there's a pattern of how mutations like happen. So first we have our wild type sequence. I'm just put wild type. And then that wild type, let's say something happened. Like let's say there's a break on the DNA. Now, this break could be repaired. And if it's repaired correctly, it will just go back to the wild type, right? But what if that break was never repaired? If that break was never repaired, we have a mutated sequence now. Right? But let's say the break was actually repaired, but it was repaired incorrectly. Now, if it's incorrectly repaired, then it will still cause mutations. That's why mutations are permanent change in the DNA. For this example, let's say the wild type is ATGCG. Now, let's say something happened, something broke, it underwent repair. That's why we still have 5 sequences here. But the repair was incorrect. That something happened and changed the sequence here. So now you have a permanent mutation. So there are different types of mutation. Point mutations basically are one nucleotide change. I don't know how else I can explain it, but think of one point, just point. So it's one nucleotide change. Now, there are different mutations that can happen if a nucleotide is changed, if just one nucleotide. If you remember, we have something called missense, right? Now, missense is a type of point mutation because only one nucleotide is changed. But even though one nucleotide is changed, it changes an amino acid. So one nucleotide change and changes amino acid. So you can think of it this way. Like let's say we have 5' AUG. We know that AUG is the code for methionine. So if this was mutated, let's say there's something happened, the mutation was AAG, I would say. Now that's a missense, right? Because only one nucleotide was changed, but it changes the amino acid that will be produced. So this type of mutation is a missense mutation. And then there's also another kind of point mutation, which is the nonsense mutation. It's kind of the same logic as missense. The only difference is that it's a change of the codon to a stop codon. So one nucleotide is changed, but it caused an early stop. One nucleotide and changes to a stop codon. So basically, like I forgot what's the codon for the stop codon, but it's kind of the same logic as this. Let's say this was AUG, and then one nucleotide was changed to make it a stop codon. Now, if you have a string of nucleotides, let's say this is the wild type over here. The wild type is this long, but let's say the nucleotide change happened here, which causes as early stop codon. So if it was mutated, you will have something like this instead, because of an early stop codon. So basically, you can think of it like it doesn't make sense. Like, why did you suddenly stop? So yeah, I don't know how else you can make sense of it, but that's how I make sense of nonsense mutation, early stop. Like for me, like if I see a car in front of me suddenly stopping, like, bro, that's nonsense. All right, I'll stop. Let's go to indel mutations. Now, indel mutations are not point mutations because it could be a one or more nucleotide changes. Now, basically, indel means insertion or deletion. So if you imagine inserting a sequence like a nucleotide to a sequence, it's gonna cause a frame shift, right? Causes a frame shift. I will show you what it looks like, but I'm just gonna start writing them down first. It causes a frame shift, right? But not every time. Why is it not every time? Why does it not always cause a frame shift? Because like the keyword is here. Indel mutations are one or more nucleotide changes. So if you had 3 nucleotides that were deleted or were inserted, it doesn't really cause a frame shift, right? Because it doesn't shift how the codons are read. Let me give an example. Let's do something like where it causes a frame shift first. So let's say this is the wild type. AUG whatever. AUCCCC. This is the wild type, right? If we had, let's say we inserted something. This is mutation. This is the mutated one. It was AUG. And then we inserted a T. So that's the mutation, right? So how does this cause a frame shift? So if you remember what codons are read by 3 nucleotides. At a time. So if you remember what codons are, this is basically what happens during a frame shift. So in a wild type, you'll see something like this, right? One codon, second codon, so and then third codon, right? Something like that, because it's 3 nucleotides each. Now, if insertion happened and it caused a frame shift, let's look at this one. We have the first codon. Now we have to read 3 nucleotides, 1, 2, 3. You see how it shifted the frame back so that you can have this. And now we count again, 1, 2, 3. You see how it shifted the frame now. Now notice the difference here. Our first 3 codons have different sequence than our first 3 codons on the mutated sequence, right? So what this causes, like it can cause a change in amino acid, or it might not cause a change in amino acid. It depending on what the codon was reading for. But basically, this is the logic of how frame shift mutation happens. So let's say the same sequence, like we have the same wild type, and let's say we deleted something instead. So 5 prime. Let's say I deleted the U instead. Now, I am pretty sure you already see what's happening here. Codons are read by 3 nucleotides at a time. So I deleted the U instead. So what happened is that I have A, G, and then the third one is A. So that will be my first codon. 1, 2, 3, second codon. Right? So this is what it means by shifting the shifting the frame of how you read the codons. I'll give you an example of how it doesn't cause a frame shift instead. So let's say we have the same mutation, we have the same sequence, file type sequence. Now, let's say the mutated sequence instead, like, we inserted 3 nucleotides. So let's say it was AUG, and then AUC, and then I inserted 3 new nucleotides, whatever it is, and then now you see, frame shift didn't really happen. Why? Our first codon, our second codon, our third codon, and then we just have a fourth codon instead. So it might have added a new amino acid, but the shift the frame didn't shift. So we still have the same codon as the wild type, same codon as the wild type as well, same thing here, and it's same thing. Not same thing, but it didn't really cause like a frame shift if we inserted 3 new nucleotides instead. Now, if, let's say we deleted 3 nucleotides, it's kind of the same logic as well. Let's say I deleted AUG instead, and then I started with AUC, and then CCC, and then 3'. So even though I lost AUG, it didn't really shift the frame because AUC would still be read as AUC on the wild type. CCC would still be read as the same thing as the wild type as CCC. So that's what it means by frame shift. Like, it didn't really cause a frame shift at all. So indel mutations are basically like that. Inserting a new nucleotide, or deleting a new nucleotide, or deleting nucleotides at all, like 3 nucleotides. It can cause a frame shift or not. Alright, so I'm pretty sure you've heard of synonymous and non-synonymous mutation. It's basically the same thing as it means. So basically, like, this is kind of like their meaning is kind of what their word is. Synonyms, synonymous. It's more referring to the final product. So synonymous mutation is more of a change in the sequence, but a change in the sequence, but doesn't change the product. Because synonymous, it means like, even though I changed the sequence, it really didn't change the product at all. Like, I don't know the codons, but let's say like the 3 codons. Do you remember like how codons, like some codons are coding for the same amino acid? So even though I changed one of the nucleotide, it didn't really change the amino acid, right? So the opposite can be said on the non-synonymous mutation, because it's not synonymous, it's not the same. So basically, it's a change in a nucleotide in the sequence as well as the product. Alright, so basically this is what it means. I don't know how to make it more simpler. Just think of the word itself. Synonymous, non-synonymous. Synonymous, like synonyms, same meaning. Non-synonymous, not the same. So basically, like a change in the sequence. If it's synonymous, the sequence is changed, but the product is still the same. Non-synonymous, the change in the sequence causes a change in the product as well. So if we're gonna classify or like put these mutations to the non-synonymous and synonymous, we'll start with missense. So missense mutation, what does it mean again? It means one nucleotide is changed, but it also changes the amino acid. So if you think about that, it changes the amino acid, which is the final product that we have for the codon. That means it's non-synonymous, right? So missense would count as non-synonymous. How about nonsense? basically it's the same thing, right? Because like you change the sequence, that means you have you have an early stop codon instead. So instead of the amino acid that you're supposed to get, you got a stop codon. So it's also a non-synonymous mutation. Alright, indel. Now, indel mutations can be synonymous or non-synonymous. Why is that? So if you remember from the example I gave you earlier, this one, it could be synonymous mutation if it didn't cause a frame shift. Because let's say this one, it didn't cause a frame shift, right? When I inserted 3 nucleotides, because AUG would have the same amino acid as the wild type, right? The second codon will have the same amino acid as the second codon, the wild type. Same amino acid, same amino acid. Even though like I inserted 3 nucleotides here, we still have the same product that we want. Even if it's deleted, we deleted AUG, our second codon will still have the same amino acid as the AUC on the wild type. The third codon will also have the same. So that could be a case on how indel mutations can be synonymous. Because even though you changed the sequence, you didn't really change the amino acid that you want. It not necessarily the product, but more like the amino acid. So correct me with this one. It's more a change in the sequence, but the amino acid didn't change, or the reading frame wasn't changed. So how is indel a non-synonymous mutation? So one case is when like frame shift, right? So let's say it caused a frame shift. Now, if the frame is shifted, it's more likely you're gonna have a different amino acid instead, right? You can see this one, AUC, TAU. I'm not sure if this is actually like if this is different amino acid. Oh wait, we don't have a T in the RNA, so I'm gonna have to correct that with something U instead. Alright, so UAU and AUC. I don't memorize the codon, but just correct me if I'm wrong, but just imagine that this codon over here and this codon over here are coding for different amino acids. So that means the product is different, right? So that's basically what non-synonymous mutation means. A change in the sequence as well as the product or the amino acid. So in this one, basically a change in the amino acid, there's a change in the sequence here. So it also changed the product. So that's one case like how indel mutations can be a non-synonymous. Same thing here. AGA would be different than AUG. So it already had a different amino acid. So that means it's non-synonymous. So yeah. If I'm gonna summarize everything, basically, first we have a wild type. Our wild type sequence. Now, our wild type sequence, let's say something happened, a break happened, so it could either undergo repair, and then if it's correctly repaired, we'll still have the same as our wild type sequence. But if it's not correct, we will have a mutation. And let's say wild type is broken and it wasn't repaired, then we will have a mutation, right? So that's why mutation is a permanent change in the sequence. Now, there's different types of mutations. We have point mutations, which are one nucleotide change, and depending on what it is, it could be a missense or a nonsense. And then there's also indel mutations that are one or more changes in the nucleotide. It could either cause a frame shift or not. And then synonymous and non-synonymous mutations are basically just like what they are called, synonyms. If it's synonymous mutation, it's a change in the sequence, but the product doesn't really change. While non-synonymous mutation is a change in the sequence as well as the product. So yeah, that's basically everything about mutations for now. I'm gonna try to cover repair in the next video. So yeah. By the way, check the description as well of every video I'm gonna be making, because some people, I've noticed like in the feedback that some people doesn't have the time to watch videos. So I'm gonna put like my notes or main takeaways of the video instead in the description, so that at least you can read it. It's probably short, but maybe it will be helpful, maybe it will not. But I'm just giving it out. So yeah, thanks for watching the video.